I've been involved with cold fusion for well and truly over a decade now. And it, for instance, cold fusion has been around for some time. In fact, even if you look into some of the historical records over the last couple of hundred years, they were in a way trying to achieve cold fusion, because it's what nature does in a way in terms of its transmutability. However, we jumped to the 1970s, the oil crisis, and there was Fleischmann's and Pons. They brought cold fusion to the world's attention because they essentially had a form of cold fusion reaction happening, and their university sort of pushed them into the public eye very prematurely, because it was the oil crisis, and suddenly, you know, we had an alternative to oil, that being cold fusion. But people weren't able to replicate the experiment very well, and cold fusion got an incredibly bad rap, to the point that academically, if you use the word, you'll virtually lose your job. These guys lost their job at their university. One of them actually ended up living in Australia, and I think the other one ended up in Canada. So that was Fleischmann and Pons. It was actually on Time magazine at the time. And, you know, the world was sort of going, oh, great, you know, we've got some sort of real great alternative to fossil fuel. Cut a long story short, they had, to a degree, a form of cold fusion happening, but it wasn't fine-tuned enough, and it wasn't, they weren't able to control it very well. So the point I'm making is cold fusion got a bad rap. It went underground. So the only people that would sort of consider it would be private labs, and retired academics would actually kind of start to dabble in cold fusion. Then what happened was, along came Andre Rossi. He's an Italian engineer, and he started to dabble with cold fusion and had access to some of the top academics in Italy as mentors. And he put a cold fusion reactor together called the E-Cat. So this is about 12 years ago. And I met Andre when he had this rudimentary form of a cold fusion reactor. And of course, there was a lot of skeptics, and people didn't quite know what was going on, but I made the effort to go and meet him and go to his factory. And he had a reactor definitely happening, and it was spitting out some steam. And if you know anything about cold fusion, I thought, well, you know, it goes into what's called self-sustain mode, that it's starting to just create energy. You don't have to put any more energy in. And so all he had to really do was refine it, etc. And so he ended up, and you'll see some slides with this, he ended up putting like over 100 of these reactors into a shipping container, because, and then it took a good couple of years to get all the reactors working together. And that's when Fulvio, this brilliant Italian engineer, became involved with Andre Rossi's E-Cat invention. So that was about 10 years ago. So Fulvio was the guy that did all the computer program. You could imagine over 100 reactors needing to coordinate. The whole idea, of course, was to get a stable energy supply and a stable output. And in those days, 12 years ago, it was about just producing heat. I mean, basically, cold fusion is a sexy boiler, right? An incredibly efficient boiler. So energy in, you heat the steam up, the steam drives a turbine, then a generator, and then you've got electricity. But before the electricity, you've got the steam, and there's a big use for industrial steam, right? Steam and high heat is used, massively all across industry, of course, and on a fundamental level, it's just used for heating, and of course, using that heat convectionally for cooling, for cooling buildings, airports, railway stations. These are massive energy costs. And if you can bring that energy cost down, you've really got something. So there was a lot of excitement around what Andre Rossi had done, but he wasn't sort of releasing too much. Well, most inventors keep things very close to their chest. So it was very controversial at the time. But what he did manage to do was fundamentally get everybody excited again about cold fusion. So we just went from 1 or 2 labs, 10, 15 years ago. When Andre came on the scene, then he was a catalyst for getting everybody kind of focused back into this idea of cold fusion. So since that time, there's been dozens of labs set up, various, levels of labs, just some with 1 or 2 people working, others with a little bit more sophistication, etc. Then, so the E-Cat went through a series of evolutions. So the next one that he brought out reached a higher temperature. You need a certain amount of that steam to be reach a certain heat for it to efficiently run these turbines and generators. Yeah. So he brought out another one that created more heat. But the trick is, he still wasn't able to bring anything to the marketplace, because essentially he wasn't able to control the reaction very well. You always had to be around, dials and gadgets and so forth, right? So I got involved in the early stage as an early seed investor. I put a serious amount of money into this because, I've been around a lot of inventors, and that first stage is the hardest stage. That's where the risk capital was involved. You get one idea that's kind of working. You just always have to take it to the next benchmark, and then the next benchmark. And if you get through, a few of these benchmarks, then you can get something to the market. And then it's easy to raise money. That's the easy part. It's always getting these inventions up to that stage. So I invested a serious amount of money, and I also raised a couple of million for him with other people as well. Now, let's just have a look at what I've got here with the, so cold fusion is a process of harnessing the energy from spinning atoms. Now, what's transpired is probably taking nickel down this road of transmutation is probably the most efficient way of doing this. In the past, people have experimented with plutonium and all sorts of other metals, but it seems that nickel is possibly the best way to go. And that's what Andre Rossi started to use. Now, the original experiments, Fleischmann and Plons, they were using plutonium from memory. Yes. And so it's called cold fusion because, as opposed to hot fusion, where it's basically like a nuclear power plant and it's requiring billions of dollars of technology, cold fusion is something that you can actually do in your garage. If you've got the right equipment and it's reaching, you just need sort of a certain amount of pressure, a certain amount of temperature. And then it's a matter of getting, this sort of cascade happening, the right frequencies, the right resonances, etc., to transmute the electrons into this cascade. And basically, you'd be essentially transmuting the nickel down to copper, right, as a little residue. But what you're marrying this with is, of course, hydrogen. So you basically got like a hydrogen capsule in the reactor. So it's the hydrogen and the nanonized, so we're talking very, very small particles of nickel coming together with a catalyst. And of course, the catalyst is the secret sauce, and the whole configuration is the secret sauce to this. So the E-Cat was just using very, very small amounts of nickel and hydrogen. And the point is, guys, this really is the holy grail of alternative energy creation, because, you know, yes, we can do a certain amount with solar, we can do a certain amount of wind and hydro, etc. And we're slowly getting there, but it's nowhere near what you need to take us to the next quantum leap in energy production that's clean and green. So yeah, so you can, at this stage, you can only do so much with the alternative things coming through, including the hydrogen economy coming through, which I'm a big fan of as well. The thing is that you need the sort of energy density. So, I mean, what you get from coal, C-O-A-L, coal, you get a lot for your buck, guys. Coal is really, really hard to replace. Look at the world; it's, you know, finding it very, very hard to replace coal, because it's a very energy dense, right? And you get a lot of release of energy from that. But it's a little bit dirty and smoky and sends the carbon up into the atmosphere. So and it's not renewable, right? So the point about coal fusion is that it has an incredibly high energy density, thousands of times more energy dense than, for instance, fossil fuel. To give you an idea of the energy density around coal fusion, 1 barrel of nanonized nickel in a coal fusion reactor process is the equivalent of a super tanker of oil, right? So that's the energy density we're talking about here. Okay, so that's just, you know, your nanonized nickel, your catalyst, your hydrogen. So there's no radioactive waste. This very, very weak gamma rays generated, which is easily shielded. So these reactors had like a leather shielding around them. And there's plenty of nickel on the planet, absolutely plenty of nickel. You only need a small proportion to provide the energy needs of mankind. So it can get pretty technical. We're not going to be doing the technical side of it today. I'm just going to take you through my involvement with coal fusion and the various steps along the journey. So for instance, with Andre's technology, I set up a website called ecat.tech, T-E-C-H, ecat.tech. But none of this actually came onto the market. So that's your example there of the all these reactors putting into a shipping container. So it's very much a modular form. And that was one of the first prototypes that he built. And that was for industrial heat. And but the trouble was he wasn't able to control it very well. You see, essentially, I mean, he got good results, right? And Fulvio built this. Fulvio was an eyewitness to all of this. Of course, this was all hidden away in a warehouse that nobody could come to. And by the way, we have tens of thousands of people following Andre's move, or used to be following this move, because he hasn't put anything onto the market. People get a little irritated by the whole thing. But he did put this together, and but again, you couldn't put it on the marketplace because you can't. Yeah, I mean, a boiler, you get a boiler in, you plug it in, and Bob's your uncle. You don't have to be attending to it with all the gadgets and the dials, etc. So that's the sort of stage that it got to. There was definitely results. Some of them were independently validated to an extent, but it just wasn't, just not fine-tuned enough. And there's also questions around the actual reactor. So we called them the warm cat because it was just generating up to 120 degrees. But then later on, the hot cat came along, and it was pumping. It was getting up to 700 degrees, right? Now, this bottom line, COP, is called a coefficient of performance. So it's what engineers use to denote the efficiency of a device. So one electrical unit in, you'll get 6 heat units out. So it's all about COP in the sense of developing something that is competitive, cost effective, and you get a bit of money for your buck. So coal has quite a strong COP. So you've got to have something similar to coal or better. So we always talk about like this minimum of COP of like 1 to 10, 1 to 20, or at least 1 to 6, right? Minimum 1 to 6, right? And cold fusion can do that, of course. When cold fusion is up and running, working well, it's very realistically to be 1 to 100 or something like that, right? Now, there were some replications of Andre's original device. There was a Russian guy that just basically started to kind of put a few little things together. And he was sort of starting to get a COP of like 1 to 4 or 5 or 6, somewhere around that mark, right? But again, there was some academic papers released around this topic that Andre was sort of part of as well. So anyway, this is just taken off the website. There's some good material there if you get the chance, if you want to get your head around the whole idea of cold fusion and its potential in the world, which is absolutely phenomenal, because basically we can replace fossil fuel just like that, right? And then you can bring a whole continent out of poverty just like that, for instance, Africa and parts of Asia, because once you get mobile, cheap energy supply, then you know that's it. That's the basis of our economy, right? So, and it's clean and zero emissions and no pollutants of any kind. So that's just a picture taken back probably about 12 years ago, when I actually went to meet Andre and organize licenses. So what he did was he actually sold licenses or territories around the world to finance his invention. So there's an example of, so there's the Time magazine article that came out about 25 to 30 years ago now. Everybody was pretty excited about that, but it kind of imploded, so to speak. On your left hand there is the E-Cat. So notice the reactors in there. And Fulvio pretty much put Andre's ideas all together in a practical sense and built that and did all the computer programming to coordinate the energy in and the energy out. Remember, you need if you're selling like 1 megawatt of heat, then the client needs 1 megawatt of heat in a consistent way. So, and then you can see down the bottom there that the E-Cat went through some various evolutions, from the first one to up to the Quark X. And Andre is talking about possibly getting another one done early next year. The thing about Andre, he's sort of a little bit difficult to work with. The communication level is become very, very, very minimal. And who knows? Who knows what he's up to? Nobody really knows. This is an example of the E-Cat, the warm cat that Fulvio pretty much put together for Andre. And they actually, so up to about 6 or so years ago, 5 years ago, they actually ran this for several months of the year and got some, reasonable results from it, but again, not good enough to be able to put out onto the marketplace. Right? So here's Andre doing various experiments. Now that's Fulvio up there on the right at one of the small conferences that we put on. Here's Fulvio working on the warm cat. And up on the left-hand side, there is a picture of the hot cat, which was reaching over 700 degrees Celsius. We put on a major cold fusion conference several years ago in Zurich, well attended by about 300-400 people. People were very excited about Andre's evolution of the cold fusion. But again, nothing was actually put onto the marketplace. There was issues around the reactor and the controllability of the reactor. And so it's still a process of research and development, so to speak. And moving forward to a degree, Fulvio, here, let's just have a little look at this. The comparison of, say, fossil fuel to hydro, wind, solar, E-Cat / cold fusion just wins across the board. And, essentially we've had the blessings of the fossil fuel age for the last couple of 100 years. As you know, the fossil fuels has pretty much got where we've got in the world today, and the affluence and the economics that have come from that. It's undeniable, the benefit, but it just can't go on. We've got to sort of now slip into a low energy nuclear reaction. That's another name for the cold fusion, low energy nuclear reactions, right? And that will take us to the next quantum leap. So we established this company, URANGARA. Now, it's a name that I thought up because it's a name that one of the Aboriginal tribes here in Australia uses. Now, as you might know, we have kind of like hundreds of Aboriginal dialects. There's not just one dialect, although there was a sort of communal words that were shared amongst the various regions and tribes, etc. But there's a lot of dialects. This is from a southern Aboriginal tribe for the name of the sun. So URANGARA is the sun, and of course that's a very appropriate name for the cold fusion reaction, because it's kind of like, in a way, recreating the sun. Now, setting up a cold fusion lab doesn't cost much money. When we just need a handful of equipment and various things to be made, as opposed to the other experiments going on in the world at the moment with other types of reactors, which cost, you've probably heard of the Helion, where they're trying to recreate the sun's energy in an artificial way, but it's costing them like billions of dollars to put all of that together, with the hope of it working. And God bless if they get results, because anybody who would get to the point where you can put something onto the market that can start to replace fossil fuels and really take us into the next area. Now, I really don't know how successful they're going to be. They've been at it, some of these bigger projects that cost billions of dollars, because I mean, the thing about cold fusion is it really is biomimicry in the sense that we really are kind of dabbling into what nature does in terms of transmutation or good old-fashioned alchemy, right? Whereas the other sort of processes that are costing billions of dollars, it's a little bit more artificial and synthetic, etc. But who knows? They could get some success with that. But again, these power plants would cost billions of dollars to build, a bit like a nuclear power plant, whereas a cold fusion plant, it doesn't cost much at all, right? So the economics are radically different there. So cut a long story short, Andre would kind of never really listen to some of the people that I would introduce him to. I'm in this unique position of knowing a number of really great inventors and innovative thinkers around the world, including Dan Winter and Elizabeth Donovan. Now, Elizabeth is an absolute genius with a number of things here. And then Fulvio, only about a year ago, basically rang me up and said, so he broke away from working with Andre about 2 to 3 years ago, out of complete frustration, right? Because essentially, you know, Fulvio started to have a lot of his own unique ideas. And also he was starting to feel very passionate about these E-Cats that he was building, you know, because he's there night and day for, you know, years building this. And so basically they had a falling out. So he came to me and said, all right, Roger, I want to work with you. Let's build, you know, a cold fusion reactor that can really, really, really work. So he's got a lot of great ideas, and I've married him with Elizabeth and myself. So there's actually just 3 people involved in the URANGARA project at this stage, right? But I really feel confident about this because basically you start to think about this, and we're the world's expert in standing wave ratios, right? And at the end of the day, that's kind of what this is about, you know. It's all about frequencies and standing waves, etc. Right? So I've got pretty good access to. I've been to a lot of cold fusion conferences, including the MIT up in Boston, and so I have some access to some good consultants. But again, we only need 1 or 2 consultants to work with us on this. So here's Fulvio, really magnificent hands-on knowledge, and who was interpreting Andre's ideas. And now here's a little expression from him. We have tried lots of things, 20 different types of reactors. I assure you there were some of them that truly seen a new world. He's seen this for himself: energy density reaction capacity, the new frontier of energy. Now, he would like to point out that, of course, the first question that might come up for you is, well, what about Fulvio's previous relationship with Andre Rossi? Well, there's no contractual obligations left. The ideas that we are developing around a successful cold fusion reactor have nothing to do with Andre Rossi's invention. So there's absolutely no conflict of interest there at all. So it's a different project. The diversity of this technique makes it completely applicable to new projects and research and development. I'm extremely excited to be working with Elizabeth and Roger on developing the world's first working LENR reactor and bringing the URANGARA project to the marketplace. And definitely the world needs us. Now, Elizabeth, as I mentioned before, brilliant innovator, brilliant thinking outside of the box, really good combination with some of the practical ideas that Fulvio's got. She wrote this book, Glimpses of, and this was done about 20 years ago, where she went through a whole number of very, very interesting and forgotten technologies around the world. So it's a great book to get into if you're interested. You can always email me and I can find a link. You might have to buy it, I think, for $10 or something from her. So we've been involved with Elizabeth on a number of other projects. She will be a consultant on the hydrogen antenna project with myself and Dan Winter as well. And so she's got some very, very unique ideas about the nickel isotopes as well, right? That now some other consultants, Jean-Paul has been to some of our breakthrough technologies conferences. We have a strong friendship bond with Dan Winter, Jean-Paul, and myself and Elizabeth. We've dabbled on, a few things together. And he's kind of like the #1 go-to guy in the world in cold fusion to kind of get things validated, so to speak, which is essentially you just do with sort of energy into water and energy out and things like that. So he's the #1 guy to validate the efficiencies of various inventions and machinery, etc. And he's done a number of publications, and he's written a book on cold fusion. And there's, I think you're familiar with my background, that I've been involved with a number of alternative energy systems and thinking outside of the box and eco orientated designs and technologies. So that one I have to flip past, because that's the, we're starting to get original ideas, a little sketch there. It's part of the secret sauce. If you're clever enough with this recording, you could freeze it and zoom in there, and you could scratch your head and see what we're up to if you wanted to. Right? One more shot. And so it goes without saying what kind of marketplace we're talking about here. Yeah. In the sense that you get something into the marketplace, it can be worked across the board for cheap desalination, just like that. Essentially, what happens is these reactors are very scalable. For instance, a 1 megawatt, right? For instance, that could be the size of a shipping container. You could just stack them on top of one another virtually to, if you wanted 10 megawatts, you have 10 shipping containers. Now, if you're in an isolated part in the middle of Africa, right? The reason why Africa hasn't got a good electrical system, look, how frustrating would it be for you if you're a young man and a woman, right? And you're 18, 19, 20, and you're in Africa, and the electricity is only on for 2 or 3 hours a day. You can't study at night, you can't dabble on this, you can't do that. It's incredibly frustrating. Now, it's very costly to put in electrical infrastructure. Now, we've got it in the West, because various reasons we've been able to figure that one out and pay for it, etc. But in many, many parts of the world, they simply don't have that because they don't have the big bucks to do it. Now, this decentralizes everything. You don't have to think in that old-fashioned way. You could set up a URANGARA power station, right, with just 20, 30, 40 of these modules stacked up, right, producing steam, going into a generator, and then on a micro scale, distributing that electricity just around that region, right, for virtually nothing compared to the old-fashioned grid system, right, involving these huge big coal power stations, or you know, hydro dam works, which, by the way, upset all the natural river systems, and can be a contributing factor for the, you know, the effluent going into the ocean and destroying the coral reefs, etc. You know, but so get the idea that they're very, very adaptable and scalable. And the idea in terms of the business side of this is we don't actually sell the technology. The technology will be obviously held top secret with security devices, etc. So people, we will just sell the energy. So if a factory is already spending, you know, $20,000 a month on their industrial heat, and we come along and say, oh, we could do that for $6,000 a month, don't you think that they'll be jumping at the chance? And the idea is that they don't have to buy the technology that could be millions and millions of dollars, right? They just basically get a bill from us, right? So the idea is you sell the energy, not the technology, right? So it just gives you a little example of how this could be achieved. Scalable, easy plug and serve, like very easy to put out into the marketplace and get happening. And of course, it can be used domestically. So imagine just a small reactor for a household, because you know you could be using that for your heating of the house during the winter time. You could be possibly using it with a generator to charge up batteries that could be used for electrical vehicles as well. So it doesn't really take much to figure that one out, you know, that it's incredibly adaptable. Okay. So across the board here. And, you know, essentially we're looking for like it's only $150,000 that we're actually looking for to actually get our lab established with Elizabeth and Fulvio and myself. And of course, we've got a budget with that. It's primarily about getting a certain amount of equipment together. Then, of course, in terms of early seed investing, we could get a number of people together to help us with this. You know, it only needs 6 people at, say, 20,000, or 15 people at, you know, 10,000. And of course, being an early seed investor, you get the first opportunity to buy more shares at what we call stage 2. So just imagine that we set up the lab and that we got our benchmark done, which is basically the first prototype cold fusion reactor done our way, right? So then imagine, oh my God, it's working. It's working really, really, really well, right? So then obviously you would need to be getting a stage 2 investment, like, you know, like $1 million, right? To build a better facility and to do more testing and scaling up, etc. Well, with your early seed investment, you're obviously got options to buy more shares, and you know, it's risk investment, so there's got to be a really, really good return for you. So it's pretty much geared up that way, yeah. Of course, establishing a location, building the reactor, testing equipment, some independent consultant fees, etc., general expenses. So we know what we want to do. We've got it all laid out, getting the wave generator and instruments for reading the power source and you name it. Pretty straightforward. Got all this written down. Possibly setting it up in Italy or Spain it's open for debate. So this is just some general business strategies. There's a quick little budget for you there. And if you're interested, you can contact me about this one. There's really lots and lots of uses for low energy reactors. So you could actually end up with one of these in a car. So forget the idea of an electric vehicle and with these titanium batteries, which I don't know about the environmental impact of all of these batteries, do you? Right? But they're good for now to clean everything up. But essentially, if you had a working cold fusion reactor, which could be quite small, you'd be basically generating your own energy in that car. In fact, you'll take that car home, plug it into the house, keep that reactor going, and it will run the house for you, right? And of course, this is the future aspect of putting spaceships into space with being a lot more efficient in the way we're going, which is basically you need a lot of energy to get that liquid hydrogen out of the Earth's orbit. That's where most of the energy goes into. Imagine if you were running a cold fusion reactor in a spaceship. No problem. The spaceship could be very light, very quick to get out of the Earth's orbit. You wouldn't be carrying all of that weight around at all. So of course, there's a lot of interest in the future use of a cold fusion reactor in cars. It would take us in trucks and all forms of transportation, big time. And to an extent, we'll be going back to steam. Now, there is this idea that, the reactor is creating heat, which, heats up the water, creates the steam, and you use a generator. But there's a lot of ideas around what's called a direct conversion from that magnetic flux that's going on in the reactor, that you can, with kind of like little antennas, so to speak, pick up on that electrical flux, and it's called a direct conversion to electricity. So from the reactor itself straight into electricity. And of course, we've got ideas about that as well. It would revolutionize flight big time. And of course, building hotels in space. And of course, really what it's all about is the asteroid mining. The asteroids have enormous amounts of trace minerals. And the idea is that instead of doing all of that on planet Earth, just go to an asteroid and do all your mining there, and end up just putting all your dirty industries on them as well, if you want, in the future. Okay, guys, so thanks for your attention. I hope you've learned a little bit more about cold fusion, and we can do some questions. We need to get more people involved with this one.
I have over 400 people. They're scientists, activists, all kinds of people that would love to hear that.
So thanks for your time.